Have you ever wondered how a man born in the 17th century could lay the foundation for our modern understanding of the universe? Picture a world shrouded in mystery, where science and superstition often walked hand in hand. Then imagine a man, Isaac Newton, stepping into that world and peeling back the layers of the unknown. From his laws of motion that govern the way objects move, to his groundbreaking theory of universal gravitation that explains the force of attraction between all matter. From his experiments with light and color that expanded our understanding of optics, to his development of calculus, a branch of mathematics that has helped shape our modern world. And let's not forget his philosophical and alchemical pursuits, which, though less famous, were no less intriguing. Join us as we delve into the life and work of Isaac Newton, one of the greatest minds in human history. Born on Christmas Day in 1642, Isaac Newton's story begins in a small English village. His life wasn't a bed of roses. Losing his father before birth and his mother's second marriage when he was merely 3, Newton spent his early years with his grandmother, an experience that left him with a sense of deep-seated insecurity. However, adversity often brings out the best in us. And this was true for Newton. His intellectual journey started at the King's School in Grantham, where he began to shine academically. Yet he was more a solitary scholar than a popular student. His life took a turn when he got accepted into Trinity College, Cambridge. At Cambridge, Newton dived deep into the world of mathematics and physics, laying the groundwork for his future discoveries. His thirst for knowledge was insatiable, and he often secluded himself in his studies. Against all odds, Newton's relentless curiosity led him to the hallowed halls of Cambridge University. At Cambridge, Newton would make discoveries that forever changed our understanding of the physical world. His 3 laws of motion, the bedrock of classical mechanics, are as follows. First, objects at rest stay at rest, and objects in motion stay in motion, unless acted upon by an external force. Think of a soccer ball on a field. It won't move unless you kick it, and once kicked, it won't stop until friction or another force slows it down. The second law tells us that the force acting on an object is equal to the mass of that object times its acceleration. In simpler terms, the harder you kick that soccer ball, the faster it will go. The third law, often stated as, for every action, there is an equal and opposite reaction, explains why that soccer ball sends you backwards slightly when you kick it. With these laws, Newton provided a new framework for understanding motion and force. Newton's insights didn't stop at motion. He also turned his attention to the stars. His theory of universal gravitation was a groundbreaking revelation. Every object in the universe, no matter how small, exerts a force of attraction on every other object. This force, gravity, is affected by mass and distance. The larger the mass of an object, the greater the gravitational pull it exerts. Similarly, the closer objects are to each other, the stronger the gravitational force between them. This theory was a game changer. It allowed us to understand the orbits of planets, the tides of our oceans, and even the trajectory of a thrown ball. Newton's mathematical formulation of gravitational force, encapsulated in his famous equation F equals G times M, 1 times M2 over R squared, became a cornerstone of physics. It's a principle that, to this day, guides our exploration of the cosmos. And just like that, the universe became a little less mysterious. Not content with unlocking the secrets of motion and gravity, Newton also shed light on, well, light itself. His curiosity led him to explore the nature of light and color, culminating in the famous prism experiment. He discovered that white light was not a single entity, but a spectrum of colors that could be separated and recombined. Newton's understanding of light went beyond rainbow colors, though. He theorized that light was composed of particles or corpuscles, a concept that contradicted the popular wave theory of his contemporaries. He also delved into the principles of reflection and refraction, influencing the development of lenses and optical instruments. It was Newton who first used the word spectrum to describe the range of colors we see in a rainbow or through a prism. His work in optics laid the groundwork for future generations of scientists and engineers. Through his work, Newton illuminated our understanding of light and color. Few books have had as profound an impact on human knowledge as Newton's Principia. An epitome of scientific inquiry and intellectual rigor, the Principia presents groundbreaking theories of motion and gravity and lays the foundation for celestial mechanics. Imagine, if you will, a world where the mysteries of the universe are suddenly within reach, their secrets unlocked by the power of mathematics and the sharpness of a brilliant mind. In the Principia, Newton details his 3 laws of motion, the cornerstones of classical mechanics, and his universal law of gravitation, a revelation that forever changed our understanding of the cosmos. The book's impact on science has been immeasurable, sparking a revolution in thought and paving the way for future generations of scientists. From its mathematical proofs to its philosophical implications, the Principia is more than just a scientific treatise. It represents a leap in human understanding, a triumph of reason and curiosity over uncertainty and ignorance. The Principia stands as a testament to Newton's genius and his monumental contributions to science. Newton's work didn't just advance our understanding of the universe, it sparked a revolution. Newton's laws of motion and universal gravitation laid the groundwork for classical mechanics, forming the bedrock of physics. They provided a new lens through which to perceive and comprehend the natural world, from the motion of falling apples to the orbit of planets. His work was a beacon in the era of enlightenment, illuminating the path for future scientists and thinkers. Moreover, his contributions to astronomy were equally monumental. By applying his laws of motion and universal gravitation to celestial bodies, he reshaped our understanding of the cosmos. He proved that the same rules governing an apple's descent to the Earth also command the moon's path around our planet. And let's not forget mathematics. Newton's development of calculus was a game changer, enabling scientists and engineers to tackle problems that were previously out of reach. Newton's revolution was not just a revolution of ideas, but a revolution of how we view the world. Isaac Newton's legacy extends far beyond his time, influencing the course of scientific and intellectual history. A titan of the scientific revolution, Newton's discoveries shaped our understanding of the universe. His 3 laws of motion remain fundamental principles in physics, while his theory of universal gravitation, a cornerstone of astronomy, continues to guide our exploration of the cosmos. In mathematics, Newton's development of calculus opened new vistas in fields as diverse as engineering and economics. His work on light and color laid the groundwork for the field of optics, revolutionizing our understanding and use of light. Beyond the realm of science, Newton's influence permeates our culture and society. He stands as an iconic figure in the history of science, a testament to human curiosity and the power of rational thought. From the laws of motion to the theory of gravity, Newton's work continues to shape our understanding of the natural world. Newton's life and work are often shrouded in myth and misconception. Let's set the record straight. One of the most enduring tales is the story of the falling apple, which is said to have inspired Newton's theory of gravity. The truth is, while Newton did recount a story about observing an apple fall in his garden, it's unlikely this was a sudden eureka moment. Instead, it was his careful observations and mathematical calculations that led to the groundbreaking theory of universal gravitation. Another common misconception is that Newton was only a scientist. In reality, he was also deeply interested in alchemy, theology, and philosophy. His writings on these subjects reveal a complex and multifaceted individual who sought knowledge across a wide range of disciplines. Debunking these myths doesn't diminish Newton's achievements. Rather, it paints a fuller picture of a man who was not just a scientist but a thinker, a philosopher, and a pioneer. Even stripped of myth, the truth about Newton's life and work remains truly extraordinary. From a humble beginning to a legacy that spans centuries, the story of Isaac Newton is a testament to the power of curiosity and intellect. His journey took him from a small village in England to the hallowed halls of Cambridge University, where he revolutionized our understanding of the world around us. His laws of motion, theory of universal gravitation, and discoveries in optics and light provided the foundation for classical mechanics, and forever changed the landscape of physics and mathematics. But Newton was more than just a scientist and mathematician. His philosophical and alchemical pursuits reveal a man deeply intrigued by the mysteries of the universe. His seminal work, the Principia, stands as a beacon in the history of science, a testament to the power of human intellect and curiosity. And so, his influence continues to ripple through time, touching every corner of modern science and society. So the next time you watch an apple fall from a tree, remember Isaac Newton and the monumental contributions he made in shaping our understanding of the universe.